In this video, we're going to talk about naming benzene rings. So to name benzene, the ring itself, is going to be our parent chain, if you will. So before we were looking for the longest carbon chain, now benzene is going to be that chain. And then what we're going to name as groups are any groups coming off of that benzene ring. So benzene is going to be our parent name, and then we will name the groups, the coefficients, kind of as we did before. So in this example, we have a 3-carbon group, which is a propyl group, and it is attached to the benzene ring. So propylbenzene would be the name for this structure. Whenever there are more than one group attached, we've got some different ways of naming. So whenever there's 2 groups specifically, there are 3 different orientations. We could have groups that are right next to each other. We can have groups that have 1 carbon in between them, or we could have groups that have 2 carbons in between them. Now notice if we went over to the next side, we'd be back to having 1 carbon in between, because we're symmetrical around the ring. So whenever you've got 2 groups and they are right next to each other, are in positions 1 and 2, we call that ortho. If the groups are on carbons 1 and 3 of the ring, that's meta. And if carbons are on 1 and 4, then we call that para. Now whether you name it using the numbers or using this prefix, it doesn't matter. Both are correct. If you're going to use the numbering, your lowest alphabetized group gets the number 1, and then you number from there. If you are using the ortho, meta, and para names, you're not indicating which one comes first, which one comes second, so it doesn't matter. So if we look at this example, we've got 2 groups. We have a propyl group, this 3-carbon group, and an ethyl group. If we number the ring, we can put groups on 1 and 2, or we could go the other direction and put ethyl on 1 and propyl on 2. So the ethyl on 1 is the best choice because E comes before P. So if we wanted to name this with numbers, we would have 1 ethyl, 2 propyl, benzene. If we wanted to name this using the ortho, meta, para, 1, 2 is ortho, so we would say ortho. Then we list the groups alphabetically: ethyl, propyl, benzene. And again, either of these names are correct. So here's a quick check. 2 groups separated by 1 carbon is said to be what? So that's 2 groups separated by 1 carbon. So that would be 1, 3, which we defined as meta. There's your answer. We can also have some special types. So if one of the groups on the ring is a methyl group, then that methyl group along with the ring is considered the parent. So methyl group on the benzene ring, that whole piece is called toluene. And then when we number, that methyl group is always number 1. So in this example, we would number giving methyl group 1. We go whichever direction gives the other group the lowest possible, which either direction gives the other group a number 4. This other group is 3 carbons, which is a propyl group. So 4 propyl, and then toluene. So we don't say methylbenzene. Methylbenzene is toluene. Because it's 1,4, we could also call it para-propyl toluene. So again, here the key is whenever you see that toluene, you know that it is a methyl group on a benzene ring, and then the other group is going to be indicated by either the ortho, meta, para or a number to tell you where it is. So here's an example. So if we work through this one, we see that we have a benzene ring. And then you always want to check to see if you have a methyl group, and in this case we do. So instead of benzene, we're going to be calling this toluene. So that means we can eliminate these first two options because both of them use methylbenzene. Instead, we want to use toluene. So next question is, which numbering system is correct? So we always know that the methyl group is number 1 if we're dealing with toluene. If I go clockwise, that puts the chloro on 1, the ethyl on 5, and another chloro on 6. If I go the other direction, I have a chloro on 1, the ethyl on 2, and the other chloro on 6. So the blue numbering system puts the second group, so the first one's a tie, on the lower number. So that we're going to use the blue numbers. So that means we have 2, 6 dichloro, 3 ethyl, and then the toluene. So that is going to be answer C. Here's another situation where we have benzene as part of our name. But here we have the benzene ring, but the group that's coming off of it is a complicated group. So we can't just call this methyl, ethyl, propyl, our simple chain groups that we've seen before. So when this is the case, what we do is we actually name the chain as the parent molecule, and then the ring is our substituent. And whenever benzene is a substituent, we call it phenyl. So we're going to number this chain. So this carbon is part of the ring, not part of the chain. So if we number the chain, we can number it 1, 2, 3, 4, 5, 6. Or we could go the other direction and number it 1, 2, 3, 4, 5, 6. If we look at the blue numbers, we have a methyl group on 3, and the phenyl would be on 6. Red numbers, the phenyl is on 1, and the methyl group is on 4. So red numbers win. So we're going to call this, we have got M for methyl, P for phenyl, so methyl comes first. So we got 4 methyl, 1 phenyl, 6 carbons is hex, and this is an alkane, so it's hexane. So 4 methyl, 1 phenyl, hexane. Here are some more practice problems. Go ahead and pause the video and see if you can name these structures, and then come back and check your answers. All right, so all of these we have our benzene ring. Remember, the first thing we want to check is to see if we have a methyl group that we would call this toluene instead. In this case, we've got 2 chains that are 2 carbons each, which are ethyl groups. So in this case, no toluene, we've got benzene. Now we can either name this with numbering or the orthometa-para because there's 2 groups. If I number, I could give the 2 groups 1 and 3. So this could be 1, 3 diethyl benzene, or 1, 3 is also called meta, and then diethyl benzene. If we look at the one on the right here, again, we've got benzene. In this case, we do have a methyl group, so what we actually have is toluene. The other group that is on our ring is this 2 carbon chain, which is an ethyl group. Remember, with toluene, the methyl is always number 1, and then we would give the ethyl number 2. So we could have 2 ethyl toluene, or groups that are 1, 2 are called ortho. So we could also say ortho ethyl toluene. Either would be correct. Next example, again, we've got benzene. We do have a methyl group, so what we actually have is toluene. In this case, we can put the bromine on 3. So we would have 3-bromo-toluene. If we wanted to use the orthometa para, 1,3 is meta, we'd have meta-bromo-toluene. For this last example, we've got 3 groups. And when you have 3 groups on a benzene ring, all you can do is number. We don't have orthometa para. So if we check to see what groups we have an ethyl group, a second ethyl group, and a propyl group. So no methyl, so it's not toluene. It is going to be benzene. Ethyl comes before propyl. So one of these ethyl groups has got to be number 1. And then if we pick, when you do rings, you almost just have to pick a place to start. We know ethyl has to be 1. So if I pick this one, I could go either direction. That would put the propyl on 3 and the ethyl on 5. I could go the other direction. That puts the ethyl on 3, propyl on 5. So I've got this 3-5 tie, and just as with any other example, tie is going to be broken by alphabetizing. So we're going to make that second ethyl number 3. Now it's also worth checking if you start and make the other ethyl number 1, but you'll find that you end up with the exact same answer. So we're going to have 1,3 diethyl, 5 propyl, benzene.